Hello students, welcome to our today lecture. In our today lecture we are going to discuss that what are the assumption of classical linear regression model. In our today lecture we are giving generic review of all the assumptions, and in our later lectures we will be discussing all the assumptions one by one in detail. So first assumption of the classical linear regression model, that model should be linear in term of parameters like beta naught, beta 1, beta 2. They should be linear. If our variables are non-linear, it is okay, but if our parameters are non-linear, then we cannot apply or we cannot obtain OLS results. The second assumption of the classical linear regression model is that x values should be variable. So x values should not be constant. So it means x, if we have x values 4, 4, 4, 4, then we cannot predict the values of y on the basis of x. It should not be this. So if x equals to 1, 2, 3, 5, 7, like 9, 10, then we are able to find out the values of y on the basis of x. So x values should be variable. The third assumption of the classical linear regression model is that x is non-stochastic. And the fourth assumption of the classical linear regression model is that there should be homoscedasticity. It means that variables should be constant over the period of time. If variables are not constant, then there will be an issue of hetero in the data, and we have to resolve this issue before applying the OLS. The next assumption is that zero conditional mean of a residual. There should be no relationship between the residuals. The next assumption is no exogeneity. It means that there should be no relationship between residuals and explanatory variables or the IVs. If there exists a relationship between independent variables and residuals, then there will be the issue of exogeneity, and we are unable to apply the OLS on that model. The next assumption is that number of observation must be greater than the number of parameters. N is number of observation and K is the number of parameters. So if we have two parameters, beta naught and beta 1, so K is equals to 2, so the number of observation must be greater than 2. So for we have let's say data for 4 years or 5 years, then we are able to estimate the values of betas. The next assumption is that explanatory variables should not be fully correlated. So it means that independent variables are not 100% correlated with each other. If independent variables are 100% correlated with each other, then there will be an issue of multicollinearity. And if there exists of multicollinearity, then our results are biased and we are unable to forecast or make policies on that result. So there should be no multi in the data set. So the next assumption is that no autocorrelation. So it means residuals are independent of each other. So it means that the error term should not be correlated with each other. So mu1 not be equals to mu2. If errors are correlated with each other, then there will be an issue of autocorrelation. So before applying OLS, we have to remove the issue of autocorrelation. The last assumption of the classical linear regression model is that model should be correctly specified. So it means that model should be correctly specified in term of linearity, and in term of parameters linearity. We have included all the specific and desired variable in our model, and the actual data set should be present in the data set. So these are the assumptions of the classical linear regression model. So in our later lectures we will be discussing each assumptions one by one in details.